Hello coders, I welcome you all. In this video, we are going to build React agent using LangChain. So let's start with what is an agent. So there are many types of AI agents. In this video, we are going to focus on one simple and useful type of agent called as React agent. By React agent, we mean an agent that works by first reasoning about the task and then taking action using tools. React stands for reason plus act. At first, the term agent may sound complex, right? But in simple terms, it is just a system that can work on a task by itself. It does this by using the intelligence of an LLM and a set of tools that we provide. Tools can be anything that the agent uses to get extra help, like search engines, databases, APIs, or even simple Python functions. Now let's understand how the agent works. So when a task is given, the agent does not respond immediately. Instead, it first tries to understand what needs to be done. It then uses the LLM to think through the task and decide which tools might help. After selecting a tool, it uses it to gather some information. But even after getting the result, it does not respond right away. It checks whether the result is enough. If yes, it prepares the final response. If not, it continues thinking. It may use the same tool again or try a different tools. This process continues until the agent feels confident. After all this, it sends the final answer to the user. Hope all of you are clear with this, right? How React agent works. It is like this. In the React approach, the agent works in a loop. Reason, act, check, and repeat. Reason, act, check, and repeat, right? At a basic level, a React agent uses an LLM to think and tools to act, that you can see here. Repeating this process until the task is completed. I'm sure now all of you are clear with how React agent works. Let's jump to VS Code and build a React agent using LangChain. So now let's create new Python file, react_agent.py. Now let's open new terminal because we have to install the required tool dependencies because our agent going to use Wikipedia and DuckDuckGo search as a tool. So let's install them first. For that, we have to write pip install Wikipedia space ddgs. Let's press enter. You can see I have already installed these tools. In my case, requirement already satisfied. Let's clear this. Let's close this terminal. Now we have installed required dependencies, right? Now let's build a React agent using LangChain. So let's start by importing the required libraries. So we are going to create web app using Streamlit. So let's import Streamlit as st. Now let's import the LangChain components from LangChain_OpenAI. Let's import chat OpenAI from LangChain.agents. Let's import this class create_agent from LangChain_community.agent_toolkits.load_tools. We have to import load_tools from LangChain_core.globals. Let's import set_debug, and from .env, we have to import load_.env. Let's save our file. You know, this class chat OpenAI is to connect to the LLM. This helps us to create the agent. This is to load external tools like Wikipedia or DuckDuckGo search any, right? Here we are making debug on to observe internal reasoning, and this is to load environment variables securely. Done. Let's move on. Next, let's load the API key from our .env file using this load_.env. Let's save our file. Done. Now let's enable debug mode so we can see how the agent thinks internally. So for that, we have to use this set_debug and we have to make it true. Done. Let's move on. Now let's create our agent first. So for that, we have to use this create_agent that we have imported here, which required three things. First, model. So shortly we will define the model, means LLM that serve as the brain of our agent, right? So model. Next, tools. It allows to fetch external knowledge, right? Means what tools our agent can use. And system_prompt means system prompt tells the LLM when to stop and respond. As you know, first our agent required model means LLM. So we have to define the model first that will act as the brain of our agent. So for that we have to use chat open AI, and let's define model is equal to GPT-4o mini. So this will handle reasoning and decision making. LLM is equal to this. Let's provide here to our agent. Next, we have to provide tools. So instead of depending only on built-in knowledge, let's allow our agent to fetch information when required, that we can do using load underscore tools that we have imported here. You can provide as many tools as you want, but here let's provide two tools, Wikipedia and DuckDuckGo search, DDG-search. Also, you can define custom tools as well, and let's assign it to tools. Done. That we have to provide to our agent. Next, we have to give system prompt. So our agent will follow a structured thinking process, not just respond instantly. For that, we have to define system prompt. So you can see this is our system prompt. I have created ReAct style. You can see you operate as an agent that uses the ReAct style of problem solving. Approach each task through an ongoing loop. Thought. Carefully consider what the next logical step should be. Action. When needed, make use of an appropriate tool. For example, Wikipedia or DDG search. Observation. Examine the tool's output and determine the next step. Keep repeating this cycle of thought, action, and observation until you have gathered sufficient insight. When you are certain about the outcome, stop invoking tools and present a clear, well-structured final answer. That you can see. This is the prompt that we have to give to our agent. Done. So you can see now our agent have LLM, tools, and system prompt. You can see here we are guiding the agent to think, act, observe, and repeat. Right? Think, act, observe, and repeat before giving the final response that we have done using this prompt. Save this, assign it to one variable agent. So now almost our agent is ready, but we are going to build web app using Streamlit, which is our interaction layer from where user can interact with our agent. So let's create title first, ReAct agent. Let's take input from the user. So st.text_input and assign me a task, and let's assign it to one variable task is equal to this statement. Done. So now let's send the task to the agent. Means if the user enters something, we pass it to the agent. So if task available, invoke the agent, agent.invoke, and here we have to give Python dictionary. First, messages as a key, list. Inside Python dictionary, we have to define role as user, comma, content as task. This one. Enter by the user. Done. Let's assign it to one variable result. So now the agent internally generates multiple reasoning steps. So we can take the last message as the final answer. So for that we have to write result from messages. Let's use the final answer after the reasoning. So let's assign it to one variable final underscore answer equal to this statement, and we have to display this final answer on our web app. So final underscore answer dot content. Let's save this. Done. So you can see we have created an ReAct type AI agent that does not just reply immediately. It thinks, uses tools when necessary, evaluates results, and then responds. That you can see, right? Hope all of you are clear with this. So now let's run our script. Let's open new terminal. This is Streamlit web app. So we have to run like this. Streamlit run ReAct underscore agent dot py. Let's press enter and you can see our GUI. Now let's ask this. Find a recent news headline about AI being used in crop disease detection. Let's press enter and here you can see reasoning process is going on that you can see, right? And here you can see now it is not using built-in knowledge but provided tool that you can see, DuckDuckGo search, right? This reasoning process that we have printed using this by making our debug on that you can see, right? And great, you can see final answer is displayed over here using this tool, DuckDuckGo search. Great, right? You can see the agent did not answer immediately from its internal knowledge that you can see this reasoning process. It decides to use this particular tool, DuckDuckGo search, to gather information. This shows the LLM can choose tools when needed. It is not limited to what it is already knows. This behavior is called tool augmented reasoning. The agent follows the ReAct style. Think, act, observe, and respond. So it reasons first and then answers. This is the way an agent works that you can see, right? Hope all of you are clear with this. Let's move on. Now let's discuss something very important. Please remember, we are not limited to available tools. Instead of external tools that we have used here, we can define our own custom tools based on our problem statement that you can see here. For example, here we are not using search or knowledge tools at all. Instead, we have created our own flight price logic and used it as a tool that you can see. Simple Python function, right? So now the agent is no longer searching the internet. It directly uses our internal function, means our created tool. In this example, we have defined a simple flight price tool that knows ticket prices between specific cities. In place of this, you can use API, right? So the agent is instructed to understand the user query, extract source and destination information, use the custom tool, and return the result. So when we ask something like, what is the price from Ahmedabad to Delhi, agent does not go to Wikipedia or not even use built-in knowledge. It does not search even the web. It simply calls our created tool and gives the answer. This clearly shows that the agents are not just for knowledge retrieval. They can interact with our own business logic, APIs, or models. So whether it's pricing, database queries, ML predictions, or internal workflows, we can plug them in as custom tools that you can see here. Hope all of you are clear with how to create agents using LangChain. Let's execute this code first. Let's open new terminal. Let's write streamlit run agent underscore test1.py. You can see flight ticket assistant agent. Let's ask what is the ticket price from Ahmedabad to Delhi. Let's press enter. You can see the ticket price from Ahmedabad to Delhi is 5200. That is from our provided tool that you can see. I'm sure now all of you are clear with how to create agents with already available tools, and also you can define your own tools, right? Let's move on.